Okay, so let's begin with this. We're done with all the concepts in differentiation. We started with these basic rules that you need to know of. They're all given in the formula sheet. If x is replaced with anything else, you also have to multiply by the derivative of that thing. This is what we did. Then we did the product rule of differentiation, quotient rule of differentiation. In the beginning, we also talked about this. When you have one function inside another function, you start differentiating from the outermost function, right? The rule that applies is the function that's the outermost function. Then we did parametric differentiation, right? That we do using chain rule. And then in the last session, we did implicit differentiation. And that is something that we do when we do not have y as the subject of an equation. We differentiate both sides with respect to x, and remember in the process that the derivative of x is going to be 1 and derivative of y is going to be dy over dx. And we make dy over dx the subject then to find the derivative. When it says you want to find a point in which the tangent is parallel to x-axis, you say dy over dx is equal to 0. When they say tangent is parallel to y-axis, in that case, you put the denominator of dy over dx equal to 0. That's what we did. We did some practice questions after that. And there were some that we listed down here that we want to do them today. 12, 33. Okay, so these two are, and also 30. Okay, so let me have them here. 12, 33, and 30. Okay, so we want to do these questions today as well, along with the others that you guys are asking. Yeah, it does require a lot of practice. It does require a lot of practice. That is important. 12, 13, 28, 20. Okay, so let's start with some of these then. Again, I'm going to try and do the questions in increasing order of difficulty, but we'll do all of them, right? All the questions that you guys are asking, inshallah, we'll do all of them today. Even if you have to extend the class time, that's okay. We'll just keep doing them until you're done with all the questions, okay? 12, 13, and 28. Okay, let me start with this one. This is question number 28 from the worksheet. Let's start with this one. All right, let's start with this. It says the diagram shows the curve with this equation where a is a positive constant. The maximum point on the curve is m. Find the x coordinate of m in terms of a. Now, it's a maximum point. How do you find turning points of any function? You differentiate them, put them equal to 0, and you get the turning point of that function, right? Let's do that here and see how you can figure that out. It's an equation in which y is not the subject, so we would have to use implicit differentiation. We say let's differentiate both sides of the function with respect to x. Both sides of this equation, we differentiate them with respect to x. Okay, let's try that. Derivative of x cubed, that is 3x squared. Derivative of xy squared, this is a product. So we have to use product rule for this. We can say x is u and y squared is v. What does the product rule look like? It's uv dash plus vu dash. U as it is, which means x as it is, into derivative of 2y. What's the derivative of derivative of y squared? Sorry, you multiply by the power, it becomes 2. Subtract 1 from the power, it becomes 2y. And then you have to multiply by the derivative of y, which is dy over dx. That's uv dash plus v as it is, that means y squared as it is, into derivative of x. What's the derivative of x? That's 1. And that's the differentiation of that product. All right. Now let's look at the next term, ay squared. Remember, a is just a constant that's multiplying, that remains as it is. Multiply by the power. What's the power? That's 2. Y remains as it is. You subtract 1 from the power, and then you have to multiply by the derivative of y, which is dy over dx, minus 3ax squared. Again, 3a is a constant that remains as it is. You multiply by the power, it gets multiplied by 2, x power 1. Derivative of x is 1. Even if you multiply by that, it does not change anything. This is what you have on the left side. On the right side, you have 0. Derivative of 0 is 0. So that remains as it is. This is the first step, and that should earn you at least 2 marks already. Just this one line, if not 3, minimum 2 marks if you've done all of this differentiation correctly. Now what we have to do is we have to make dy over dx the subject. Okay, so how can we do that? Let me simplify this first so it becomes a bit less confusing. And then what I'm going to do is I'm going to write the dy over dx terms together as well. So I'm writing 3x squared first, and then y squared, and then that last term from there, which is minus 6ax. Then the dy over dx terms, 2xy times dy over dx, that's this term, plus 2ay into dy over dx. This equals 0. All right. What we do now is we take dy over dx common from the terms that have it and take everything else to the other side. Let's take all of these 3 terms to the other side and see what that gives us. 2xy into dy over dx. Let's actually take dy over dx common in the same step. Dy over dx times 2xy plus 2ay. This equals 6ax minus 3x squared minus y squared. Now, what are we looking for? We are looking for the x coordinate of this maximum point. That's what we want to find out. Did they ask us for the derivative explicitly? Well, they did not. So it's not necessary that you take this to the other side and then write the derivative. Since you're looking for the turning point, you can just put dy over dx equal to 0 here right away without even making dy over dx the subject. You can put it to 0 right away because that will just get rid of this whole thing on the left side. And that simplifies things. On the right side, we have 6ax minus 3x squared minus y squared. This is an equation that we have in terms of x and y now. Okay, 6ax minus 3x squared minus y squared. All right. Now, we need another equation in terms of x and y. That's this original equation. We can solve these 2 things simultaneously, and that should give us the coordinates of the x coordinate of that point. So, okay, so we're only looking for the x coordinate. We don't want the y coordinate. Okay, we'll keep that in mind. What's the function? The function is x cubed. The original equation is x cubed plus xy squared plus ay squared minus 3ax squared equal to 0. And now the idea is we want the x coordinate of m, so we have to eliminate y from these equations, right? So we can make y the subject and put that in the other equation. In the first equation, if I make y the subject, I get y squared equal to 6ax minus 3x squared. And now I can take square root, but when you take square root, you have a problem that you have to put plus minus, and that complicates things a little. Let's look at what you have in the other equation. In the other equation, you have y squared and you have y squared. So you can just input this directly there. Since there's no y, there's only y squared in the other equation. You can say, let's input y squared equal to 6ax minus 3x squared. This. And now we can simplify this. This gives us x cubed plus x times 6ax minus 3x squared plus a times 6ax minus 3x squared minus 3ax squared equal to 0. Let's simplify this further. We get x cubed plus 6ax squared minus 3ax squared plus 6a squared x minus 3ax squared minus 3ax squared. This equals 0. And if you think about it, these three terms are the same. 6ax squared minus 3ax squared minus 3x squared, obviously. So they will get cancelled. Let me check my working, and please do look out for any careless errors since I'm looking at too many screens at the same time. I do sometimes end up doing careless errors. Let me just check my working quickly again. 6x squared minus 3. Yeah, this was 3x cubed. This is 3x cubed, not 3ax squared. And then 6a squared x minus 3ax squared. Yeah, okay, all right. And now it looks better because now these are canceling out. 6ax squared minus 3x squared minus 3x squared. They get eliminated. And we are left with x cubed minus 3x cubed, which actually becomes minus 2x cubed when simplified, plus 6a squared x equal to 0. Right? These terms, they become 0. Now we need to make x the subject. What we can do now is we can take x common from here, or even 2 common or minus 2 common. So if I take minus 2x common, for instance, what am I left with inside? I'm left with x squared minus 3a squared inside. Right? This is what we're left with. And now we can say either minus 2x equal to 0. It's a product, right? The product is equal to 0. That means either the first thing is equal to 0 or the second thing is equal to 0. Now the first one gives us x equal to 0. The second one gives us x squared equal to 3a squared. And then x equals plus minus square root of 3a squared. Square root is on that whole thing. And then that leaves us with plus minus square root of 3 times a outside. All right. Now, what were we looking for? We were looking for the coordinates of the point M, the x coordinate of the point M. Now, that's on the right side. That's supposed to be something that is positive, right? X coordinate is supposed to be positive. We know that a is a positive constant. What that means is this point x equal to 0, this is definitely not M. Amongst these two as well, we only consider the positive case because the x coordinate of M is supposed to be positive. So x equals plus square root of 3 times a. That's the x coordinate of the point M that we are looking for. And that's your final answer. Is that all right? Make sense? That's the x coordinate of that point M. That's what we were looking for. Square root of 3 times a. A is outside the square root like this.
Sir,
Yes.
according to this working, x equal to 0 would also have a stationary point.
No, actually, what's happening is at x equal to 0, you have this curve going downwards like this. It'll have some negative gradient. And you have the other curve going like this. Okay, I'm sorry, the other way around. This part has positive gradient. It's going in this direction. And the other part here, it has negative gradient. Now, this positive value of one part of the curve and this negative value of the other part of the curve, they have the same numerical value. So they're actually canceling each other out. And the result is 0. So the overall gradient at this point becomes 0. Because of that, we are getting x equal to 0 here. Now, this is not a maximum or a minimum point, but it just happens to be that the gradient at this point, when we do it using differentiation, it turns out to be 0 because the positive and negative parts, they're canceling each other out. Okay?
Yes, sir. Okay.
All right, let's move on to the next one. This was question number 28. Okay, I'll now take one from somebody else. 28 is answered for you guys now. What's the problem with this, Ibrahim? 34, part 2. Okay, part 2 of this. Okay, let's look at this later on because gradient is equal to 2. All you have to do is cot of t equals 2. That becomes 1 over tan t equal to 2, and tan of t equals 1 over 2. You solve this, find the values of t in this given interval. Once you have that, put that value in this equation here. Okay, we'll come back to it at the end. Okay, I'll see what the problem might be in your working. Let's have a look at this later. Okay, so we'll have a look at that. Let's do some complete question now. 12, 20, 21. Okay, let's do one of 20 and 21. So we have multiple people asking about these two as well. Okay, 20 and 21. Okay, let's start with this one. Question number 20. And after these two, I'm going to go to those more difficult questions that I've pasted in OneNote already. Let's do this one first. This is question 20. All right, question number 21 from the worksheet. It says the diagram shows the curve with parametric equations, these, where t is between pi over 4 and 5 pi over 4. We need to show that dy over dx equals this. First of all, how can we do that? X equals sine t plus cos t. That's one equation. And the other equation is y equals sine cube t plus cos cube t. Remember, what's the proper mathematical form for this? It's sine t whole cube plus cos t whole cube. And that's the proper form of writing this. Okay, now, what's the derivative of this dx over dt? Derivative of sine is cos, so it becomes cos of t. Derivative of cos is minus sine, so it becomes minus sine t. That is dx over dt. What about the other derivative, dy over dt? This is a power function, right? So we have to use power rule. We multiply by 3, subtract 1 from the power, so it becomes sine t whole power 2. Multiply by the derivative of the base. What's the derivative of sine? It is cos, so we multiply by cos. Plus differentiation of this, again multiply by the power, subtract 1 from the power, it becomes cos of t whole squared, and then you have to multiply with the derivative of the base, which is minus sine t. Let's simplify this. This gives us 3 sine square t times cos t minus 3 cos squared t sine t. Okay, this is what we're getting from this. This is dy over dt. So we differentiated both of those equations separately. Now we can find dy over dx using the chain rule. Dy over dx, what is that going to equal? It's going to be product of two fractions. In the first fraction in the numerator, we would have dy. In the second fraction in the denominator, we would have dx. And then in the remaining two places, we have dt and dt. Now what's dy over dt? That's this expression on the right. So it becomes 3 sine squared t times cos t minus 3 cos squared t times sine t multiplied by dt over dx. That's reciprocal of this. That's 1 over cos t minus sine t. Okay, so that's what dy over dx is turning out to be. We have found the derivative. Now after this, it's basically trigonometry. You have to prove that this thing can be written like this. So we have to simplify this and prove that it can be simplified to this form. Now, how can we do that? Let's think of this now. In the numerator, we can take 3 common, and we can take sine common, and we can also take cos common. Inside, we would be left with sine t minus cos t. In the denominator, we have cos of t minus sine of t. Okay, so can we cancel these two out? Not yet. One is sine t minus cos t and the other is cos t minus sine t. Remember how we switch these terms? We can multiply with negative, or we can take negative common from the denominator. Let's say this was cos t minus sine t, right? I want to cancel it with this thing. What I can do is in the denominator, if I take minus common, what am I left with inside? If I take minus common, inside the bracket, I would be left with sine t minus cos t. And then this thing and this thing, they can get cancelled. We have minus here that goes to the numerator, and we get minus 3 sine t cos t. That's what we wanted to prove. Dy over dx equals this. That's the first part. Make sense? Let's move on to the next one. That was part 1. Now the next part says, find the gradient of the curve at the origin. Gradient of the curve at the origin. Okay. At the origin, x is equal to 0 and y is equal to 0. We have minus 3 sine t cos t here. This is the derivative. What value of t do we input here when x is equal to 0 and y is equal to 0? So at the origin, both x and y are equal to 0. So what you can do is you can input x equal to 0. That's simpler because y is more complicated. That has sine cube t cos cube t. What I can do is I can use this equation, x equals sine t plus cos t. At the origin, x is going to be equal to 0. So we can put x equal to 0. What does that give us? 0 equals sine t plus cos t. How do we find the value of t from this? We can convert it to tan, right? If we take cos to the other side, it becomes sine t equals minus cos t, and then sine t over cos of t, that equals minus 1, which means tan of t is equal to minus 1. Now the interval is from pi over 4 to 5 pi over 4. All right, what do we do now? We find the basic angle. Tan alpha is 1. What's the basic angle on your calculator? Pi over 4, right? That will be the basic angle. Tan is negative. Where is tan negative? Tan is negative in the second quadrant or in the fourth quadrant. So we can either be here or here. The basic angle is pi over 4 here. What's the angle that we're getting? This angle, t is going to be pi. Pi is the angle in a straight line. Subtract from that pi over 4, and that is 3 pi over 4. This angle is 3 pi over 4. That means the value of t is 3 pi over 4 at the origin. Is that in the interval that we have given? Yes, 3 pi over 4 is within this interval. If we go beyond this and find an angle in the fourth quadrant, that will be outside the interval. Okay, but it doesn't even matter because we found one value of t and that's enough. We can just input that value of t in this now and see what the gradient turns out to be. We say let's input t equal to 3 pi over 4 here. What do we get? Minus 3 sine of 3 pi over 4 times cos of 3 pi over 4. You can evaluate this on your calculator and see what that turns out to be. What do we get from this? They don't want an exact answer. That means working is not important. You can write down the answer directly. What's this? It will be under root 2 over 2 times under root 2 over 2. That's 2 over 4, 1 over 2, and then negative with that 3 over 2, right? Is it 3 over 2? 1.5, yeah. So it turns out to be 1.5, right? That's the gradient that we were looking for. This is the gradient at the origin. Make sense? At the origin, the value of t was 3 pi over 4. We found that first, and then we just put that value in that equation to find that gradient. That was part 2. Let's look at the next one now, part 3. Part 3 says, find the values of t for which the gradient of the curve is equal to 1. Okay, so now the gradient has to be equal to 1. Giving an answer is correct to two significant figures. What's the gradient? Gradient of the curve is given by dy over dx. They are saying the gradient should be 1. So we put dy over dx equal to 1 in this case and find the value of t from that. Okay, now let's try doing this. Now, dy over dx is equal to minus 3 sine t cos t. Gradient is equal to 1, so we put this equal to 1. 1 equals minus 3 sine t cos t, and we're given an interval for t. They're saying t is supposed to be between pi over 4 and 5 pi over 4. Right? Okay. So we need to solve this equation for this interval. That's what we have to do. Now, how do we solve this equation? Remember, in order to solve a trigonometric equation, we want to convert everything to just one type of function and one type of angle. Now, we only have one angle, that's t, and that's okay. But there are two functions, one is sine and the other is cos. How do we convert it to one function? Is there any identity that we can use here? So that's very good. So you can look at the formula sheet and see, where do you see sine and cos multiplying there? Where in the formula sheet you see sine and cos multiplying? In the formula sheet, you'll have that in front in all such questions. Okay, so this is the formula sheet, sine times cos. Where do you see that in the formula sheet? Okay, so you have sine times cos here. But in this case, you also have cos into sine. Where do we get that from? As in cos A into sine B for other angles. That will be difficult to get in that. Anywhere else that you see sine times cos, that's here. Sine A cos A, the double angle identity for sine. Okay, now let me go back here. We know that sine of 2A is the same as 2 sine A cos A, right? Now, what does that mean? We can say that becomes 1 over 2 sine of 2A. That's identical to sine A cos A. So this thing here, sine t into cos t, I can replace that with 1 over 2 times sine of 2t using this identity. Right? If sine 2a is 2 sine A cos A, then 1 over 2 sine 2 is equal to this. So in place of sine t cos t, I'm inputting half sine 2t. And now this is something that we can solve. Yes, you can also do that if you want in this equation. Another way to think about this could be that you could write it as, it's an equation, right? We can apply the same operation on both sides. You could say, let's multiply both sides by 2 here, minus 3, and then inside you could have 2 sine t cos t. And then you could replace this part with sine of 2t. That's equivalent to what we did earlier. So both of the methods are okay. You can do any of them. This is what we get at the end. Okay, you can do it either way. All right. And now this becomes sine of 2t equals minus 2 over 3. And now we need to solve this equation. How do we solve this equation? Remember, the angle is 2t now, and the interval that we're given is for t. So we also have to adjust that interval. Now, for problems like these, what we generally do is, to make things simpler, we use a substitution. We say, let a equals 2 times t. And then this equation becomes sine of a equals minus 2 over 3. What's the interval going to be for a? If a is equal to 2 times t, when t is pi over 4, what's the value of a? pi over 2, right? 2 pi over 4, that's pi over 2. When t is equal to 5 pi over 4, let's input that here. 2 times 5 pi over 4, what does that become? 5 pi over 2. So the interval for a, therefore, is 5 pi over 2. When we solve this equation in terms of a, we will be looking for all possible angles within this interval now. Now, how do we solve this? We find the basic angle. Sine alpha equals 2 over 3. What's the basic angle from this? It's in radians, remember? What do we get? In radians, sine inverse of 2 over 3. That's 0.7297. 0.7297. That's the basic angle that we're getting. All right. Now we think of quadrants. Sine is negative. Where is sine negative? It's negative in the third quadrant and in the fourth quadrant. So we can consider the basic angle here or here. We start measuring from the positive x-axis. The interval is only positive values of a, so we have to go anti-clockwise. The first angle that we get is this one. What's this angle? A is equal to pi plus 0.7927. Another angle that we get is this one now. That's 2 pi, angle in a full circle, minus alpha, which is 0.7297. Now, if you go beyond this, if you go one full circle and come back to any of these points, you will see that you will go outside the interval. Okay, because when you go one full circle, this is pi, 0 pi over 2, pi, 3 pi over 2, and then 2 pi, and then this is going to be 5 pi over 2. Okay, you can't go beyond that after one full circle. So you only have these two possible values of a in the interval that we have for a. Now, once you have these two values, you put that substitution back. In place of a, you put 2 times t. You get 2t equal to pi plus 0.7927 and 2t equal to 2 pi minus 0.7297. And you can find the values of t from this. What are the values of t that we get? What is t equal to? What values of t do we get? Okay, so one value that I'm getting is 1.967, that rounds off to 1.97. And then another would be 2 pi minus 0.7. So we're saying that's 5.55. Okay, so these are the two values of t that we get. Okay, 1.97 and 5.55. This is how we can write them to three significant figures.
Sir?
Yes. Okay, so the question says two significant figures. So you would say this is 2.0, and since you have 5.553 here, this rounds off to 5.6. Yes. Is that what you were saying?
No, sir, I had a question.
Yes.
So, sir, if we had a angle in the first quadrant of 0.1 radians,
Yeah.
then we would come back and plus that in 2 pi and get another answer.
Yes, then that's correct. So if you were also considering the first quadrant, yes, if there was an angle here and that was less than 5 pi over 2 after going one full circle, yes, you would also have to consider that. Okay. That's why adjusting this interval is very important. In this question, it does not make any much difference, although I think it still does because, yeah, so in this question as well, if you had not adjusted this interval, you would miss out on this possible route. So adjusting this interval is very important. Otherwise, you can miss out on possible routes in the given interval. Okay, is this all right then? Those of you who asked about this question, are there any problems? Okay, let's look at the next one now. This was question number 20. Let's look at the next one. After 20, let's do 21, and then we do 13, 30. Okay, so we have a lot of questions lined up. Okay, 21. Let's do this one next. Okay, this does not look that difficult, but we'll gradually now increase the difficulty level for the next few questions now. This was question number 21. Okay, so it says equation of a curve is this. Find the gradient of the curve at the point 2 minus 3. Now, y is not the subject. How do you find the derivative of this? You'll have to use implicit differentiation. Derivative of 3x squared, that is 6x. Derivative of minus 4xy, it's a product. You can keep 4 outside. And then this is u, this is v. uv dash plus vu dash, right? X as it is into derivative of y, which is dy over dx, plus y as it is into derivative of x, which is 1. Okay. And then derivative of y squared, use the power rule, 2y times dy over dx. On the other side, you have 45. Let's simplify this. You get 6x minus 4x dy over dx minus 4y plus 2y dy over dx, that equals 45. Now take dy over dx common from these two terms, this and this. So it becomes dy over dx times minus 4x plus 2y. Take all the other terms to the other side, 45 minus 6x plus 4y. So
Wouldn't 45 be 0?
okay, I'm sorry, I missed that. So that's a common careless error that happens in the exam as well. I forgot to differentiate 45. You have to differentiate both sides, right? The derivative of 45 is going to be 0 here. Yeah, thank you for pointing that out. The right side should be 0 there. Once we differentiate 45, it should become 0. Okay. So dy over dx is minus 6x plus 4y divided by minus 4x plus 2y. And now we put that point here. The point is 2 minus 3. In place of x, you put 2. In place of y, you put minus 3. And you would get that gradient. What's this? Minus 6 times 2 plus 4 times 4 times 2. Minus 3, sorry. Divided by minus 4 times 2 plus 2 times minus 3. And that will give you the gradient at this point. What do we get from this? Minus 24 divided by minus 14, which is 12 over 7. Is that what we get? 12 over 7? Yeah, okay, good. That's the first part, really straightforward. Now it says show that there are no points on the curve at which the gradient is equal to 1. Now, how do we think about this? There should be no points on the curve where the gradient is equal to 1. Now we have the derivative already, right? The derivative is dy over dx equal to minus 6x plus 4y over minus 4x plus 2y. Now, if there are no points on the curve where the derivative is equal to 1, if we input dy over dx equal to 1, we should get no values of x and y, right? So that's what we do. We say, let's input dy over dx equal to 1 here and see what we get from that. So we have 1 equal to minus 6x plus 4y divided by minus 4x plus 2y. Now take that to the other side and you get minus 4x plus 2y equals minus 6x plus 4y. And this turns out to be 2x equal to 2y and x equal to y. Okay, so if the derivative is equal to 1 at any point on this curve, x should be equal to y at that point. All right. Okay, now why is that not possible? Let's look at the curve. Let's input this in that original curve. The curve is 3x squared minus 4xy, 3x squared minus 4xy plus y squared equals 45. Let's solve it simultaneously with that. In place of y here, let's say we input x. What do we get from this? We get 3x squared minus 4x times x. That becomes 4x squared, right? Plus x squared equals 45. And that gives us 3x squared minus 4x squared plus x squared equals 45. And that gives us 0 equals 45, which does not make sense. That means there are no solutions from this. That means there's no point at which the gradient is equal to 1, because when we put the gradient equal to 1, we get no solutions from that. Make sense? Can we move on to the next one? Okay, so that was question number 21. Okay, let's do the next one now. Question 13. Question number 13 from the worksheet. Bilal, just the first part of this or the second part as well?
Sir, the first part was the problem, and then I didn't continue.
Okay.
You can do the first part only. The second one is straightforward.
Yeah, let's do the first part. Okay, the equation of a curve is this. Show that dy over dx is equal to minus y over x squared. Okay, now let's try this. X ln y equals 2x plus 1. We need to find dy over dx, and dy over dx is in terms of both x and y. Y is not the subject here, so we can use implicit differentiation. It's a product on the left side. This is u, and this is v, let's say. So what's the product rule? What does the product rule say? uv dash plus vu dash, that will be the derivative when we differentiate both sides with respect to x. Differentiate both sides with respect to x. What do we get from this? U as it is into derivative of ln y. What would that be? Derivative of ln of anything is 1 over that thing. So 1 over y times the derivative of this, which is dy over dx. That is u v dash plus vu dash. That means v as it is, ln y as it is, into u dash, derivative of x is 1. That equals derivative of 2x, which is 2, and derivative of 1 is just 0. This is what we end up getting. And now from this, we get x over y into dy over dx plus ln y equal to 2. And now if we try to make dy over dx the subject, that gives us 2 minus ln y here. And on the other side, we have x over y right now. Let's multiply y on the other side and divide x on the other side. And that ends up giving us dy over dx equals y times 2 minus ln y divided by x. This is what dy over dx turns out to be. This is what I'm getting at until this point. Now, if we were just finding the derivative, this would be all right. This is correct derivative, and that's okay. But they don't just want us to find the derivative. They want us to prove that the derivative is actually equal to this. Now, the problem is, how do you go from this form to that form? Now, one major difference between the two forms is the form that we're getting, it has log of something. And what they have here, they don't have any log here, right? One way to get rid of this log here could be that in this original equation, if I were to make L and Y the subject, that gives me 2x plus 1 over x. At this step here, in place of L and Y, I can input 2x plus 1 over x. Okay. Why? Because I want to get rid of this L and Y. How do I do that? And this is the equation that connects y and x. If I make L and y the subject from there, I can write that as 2x plus 1 over x. So that's what I do here. I say, let's replace L and y with that thing, which is 2x plus 1 over x. 2x plus 1 over x from that original equation. So I'm replacing this thing with this. Okay, so now we have gotten rid of L and Y. Now we can simplify this. How can we do that? We can take x as LCM of the fraction of whatever is inside there, inside the bracket. So it will become 2x minus. Now be careful. This is a very common error with fractions. This negative is with the whole fraction, remember? So when you simplify this and take LCM, in the numerator, you would have 2x minus 2x minus 1 divided by x. And in the denominator, you have x. This x will go to the denominator, so it becomes y times minus 1. 2x and 2x, they get cancelled, divided by x squared. And that gives us minus y over x squared. Okay? So if you end up starting it like this, like I did, you get L and Y in your result, and then you have to think of how to eliminate that. The original equation has this. We made L and Y the subject from there. We put that here, and then we just simplify everything. We get that form that they're looking for. dy over dx equals this. Is this all right? Any problem with this? But I think there will be another more efficient way of thinking about this as well, because you see, if you look at the final result in the beginning, this is what we want at the end, right? Minus y over x squared. Now, when you start doing this differentiation process, you realize right away that there's a problem that we are getting L and Y even after differentiation. And in the result that they want, there is no L and Y. So in the beginning, what you can do is to simplify this whole process. You can first of all take this x to the other side. Yes, Ibrahim, that's correct. So you can take x to the other side, and that will simplify this process. L and y equals, if we divide by x on the other side, you get 2x over x. What's that? That's just 2 plus 1 over x. And you differentiate it at this point now. Let's differentiate both sides with respect to x after this. Differentiate both sides with respect to x. Now, when we do it after doing this step, we don't have to use the product rule on the left side anymore. So the derivative of L and y is just going to be 1 over y times dy over dx. Right? Derivative of ln of anything is 1 over that thing, but then you have to multiply by the derivative of this, which is dy over dx. On the other side, you have 2. What's the derivative of 2? It's 0. And what's the derivative of 1 over x? You can think of that as x power minus 1. You add another step here. Ln y equals 2 plus x power minus 1. So it becomes 0. Derivative of this minus 1 times x power minus 2. And you get 1 over y times dy over dx equals minus 1 over x squared. Multiply y on the other side, and you get dy over dx equal to minus y over x squared. And that's much quicker and much simpler. If you realize in the beginning that if you're getting L and Y in your derivative, it might be a good idea to take x to the other side first and then differentiate after that. Okay? Does that make sense? Okay, good. So that was question number 13 now. Now I'm going to do those questions that I've already pasted here earlier. 30, 12, 33. Just look at these questions one by one, and then if there are any more after that, we could have a look at them as well. Okay, so these are 3 questions that some of you asked yesterday, and they are the relatively more difficult ones from the worksheet as well. We have parametric equations of a curve. We need to show that dy over dx equals this. Okay, now how can we do that? X equals e raised to power minus d times cos of t. Y equals e raised to power minus d times sine of t. These are parametric equations. We can differentiate each equation separately. Let's differentiate the one on the left side. That gives us dx over dt. This is a product. If you find it difficult to do it in a single line, you can do it separately like this. You say this is u, this is v. Find u dash separately, find v dash separately, and then input values in the product rule. Okay. If you've done enough practice, then gradually you'll get comfortable doing it directly like this. The derivative is going to be uv dash plus vu dash, right? Now u as it is, that means e raised to power minus t as it is, into derivative of cos. Derivative of cos is minus sine. This is one of the most common errors in the exam. Derivative of sine is cos, derivative of cos is minus sine. And when we do integration later on, integration of cos is sine and integration of sine is minus cos. Now, a lot of people end up making sign errors here. You have the formula sheet in front. If you're confused, please make sure to look at the formula sheet and don't make that error, okay? Derivative of cos is minus sine. So it becomes minus sine t plus vu dash. Okay, now what would that be? V as it is, that means cos of t as it is, into derivative of e raised to power minus t, that will be e raised to power minus t times minus 1. Derivative of minus t is minus 1, so you multiply with that. And now you simplify this. This gives you minus e raised to power minus t sine t minus e raised to power minus t cos t. And that's what dx over dt turns out to be. Now, this is y in terms of t. Let's find dy over dt from this and see what that is. Again, we have to use product rule, right? We can say this is u and this is v. And again, the derivative is going to be uv dash plus vu dash. Okay, u as it is, e power minus t as it is, into derivative of sine, that is cos t, plus sine t as it is, into derivative of e power minus t, which is e power minus t times minus 1. Let's simplify this now. It gives us e power minus t times cos of t minus e power minus t times sine of t. Okay, so we have dx over dt and we have dy over dt. Okay, sorry, this was dy over dt, not x. So we have both of these now, dx over dt and dy over dt. What do we do next? We have to find dy over dx. We use chain rule for that. It's going to be product of two fractions. The first fraction is going to have dy. The second fraction is going to have dx. And in these places, we have the third variable, which is t in this case. So dt and dt. dy over dt, that's e raised to power minus t times cos t minus e raised to power minus t times sine t. Multiply this with dt over dx, which is reciprocal of this. And that becomes 1 over minus e raised to power minus t sine t minus e raised to power minus t cos t. Okay, now can we simplify this a bit? Since e raised to power minus t is there in every single term, we can cancel that out, right? We can take that common from the numerator, taking care of any sign errors that might happen. Be careful when you're working. Cos t minus sine t, if I take e raised to power minus t common outside, this is what I'm left with inside. In the denominator, if I take e raised to power minus t common, I'm left with minus sine t minus cos t inside. Okay. Now, e power minus t and e power minus t, they get cancelled. And we're left with cos of t minus sine t divided by minus sine t minus cos t. Okay, so we have simplified everything. This is what dy over dx is turning out to be at this point. Now we think of what we want at the end. What do we want at the end? The final result that we want is tan of t minus pi over 4. So we have to somehow convert it to that form. Tan of t minus pi over 4. Now, how do we do that? We have a compound angle here. It's much more difficult converting a single angle to a compound angle as compared to going the other way around and converting this to this form. So at this point, what I would suggest would be you stop working on this, right? Leave the derivative as it is right now and use the form that they have given there. What's the form that they have given? They have given that dy over dx is equal to tan of t minus pi over 4. You have to prove that the derivative is equal to that. That's what you have to prove, right? Now, since we have found the derivative already, we can also go the other way around. Now we can say, okay, this is the derivative. What if we prove that the derivative that they have given, that's the same as what we have found here? Can we do that? That will be much simpler because we just have to use the tan identity here. What's that? Let me write that down here. It's written in the formula sheet, tan of a minus b, that is identical to tan a minus tan b divided by 1 plus tan a tan b. That's the identity that we use here. To simplify this, what do we get? Tan of t minus tan of pi over 4 divided by 1 plus tan of t times tan of pi over 4. Now, what's tan pi over 4? You can evaluate that on your calculator. Tan pi over 4, that is 1. So in the numerator, you get tan t minus 1. In the denominator, you have 1 plus tan t times 1, which is just 1 plus tan t. So this is what we're getting, tan t minus 1 divided by 1 plus tan t. No, I said the other way around, half. I said going from single angle to compound angle is more difficult as compared to just expanding the compound angle and going to single angle. So what we're doing, this is simpler, right? That we expand this compound angle. This is much simpler to do. The other way around can also be done, but it'll require a lot more thinking. Okay, this is going to be quicker. Okay, so this is what we are getting from the form that they gave in the question. All right. Now, how do we go from this form to this form? In the form that we got, we have sine and cos. So we can convert tan to sine over cos. Let's see what happens when we do that. We get sine of t divided by cos of t minus 1 divided by 1 plus sine t over cos t. Now let's take LCM both in the numerator and in the denominator. In the numerator, we get sine t minus cos t divided by cos of t whole divided by cos of t plus sine t divided by cos of t. All right. And now cos t and cos t, they get cancelled. What are we left with? Sine of t minus cos of t divided by cos of t plus sine of t. Okay, so what we were getting there was this, and this is something very similar, but there's still a slight difference. In the numerator, we have cos t minus sine t. They have sine t minus cos t. In the denominator, we have minus sine t minus cos t. They have cos t plus sine t. How do we go from that form to this form? We can just multiply this by -1, right? Multiply the numerator and the denominator, both of them with -1, just like we did with some questions yesterday as well. Multiply and divide by -1. What happens when we do that? In the numerator, we get sine t minus cos t, and in the denominator, it becomes sine t plus cos t, and that's exactly the same thing as that. That means this thing can therefore be written as tan of t minus pi over 4 using this idea that we did on the right side. If you had to go the other way around, what you would do at this point would be apply these steps in this order. So the next step would be you divide the numerator and denominator both by cos of t to get this form. Then you split those fractions and get this, convert it to tan, and then think of it yourself that okay, one can be written as tan of pi over 4 because they're equivalent. So you write like this, and then you go back to this form. That's much more difficult to do. It's possible, but it requires a lot more thinking. So this is much easier that you expand that compound angle and then prove that it becomes the same thing that we're getting in this case. And that's going to be a complete proof for this. That was question number 30. Is that all right? Okay, that was question number 30. Let's move on to the next one now. Okay, so the next is question number 12 from the worksheet. Let's try this. Question number 12 from the worksheet. The diagram shows this curve. Now, those of you who have not done enough practice, these questions will look very difficult for you because these are like some of the most advanced questions. You can only do these once you've done the relatively easier ones and the medium difficulty level ones. Otherwise, these questions are going to be kind of demotivating for you. So please make sure that you're practicing all the assigned questions, and when you go in that order, you'll gradually start understanding the more difficult questions as well. Okay, so the diagram shows the curve y equals this. By first differentiating 1 minus x over 1 plus x, obtain an expression for dy over dx in terms of x. Hence show that the gradient of the normal to the curve at the point xy is this. Okay, so how do we think about this now? We have this curve. It's shown on this diagram. They're saying by first differentiating 1 minus x over 1 plus x. So let's first of all differentiate this thing. 1 minus x over 1 plus x. Okay, so what's the derivative? So this is the notation that we can use here. Derivative with respect to x of what? 1 minus x or over 1 plus x. How do we differentiate it? It's a fraction. We can use the quotient rule on this, right? It'll become vu dash minus uv dash divided by v squared. Okay. The numerator is u and the denominator is v. Now, what does this become? V as it is, that means 1 plus x as it is, into derivative of u, which is 1 minus x, right? 1 minus x, derivative of that is -1, minus u as it is, that means 1 minus x as it is, into derivative of the denominator, which is just 1, divided by v squared, which is 1 plus x whole squared. Okay, let's simplify this. We get -1 minus x minus 1 plus x divided by 1 plus x whole squared. And this turns out to be -2 over 1 plus x whole squared. This is the derivative of this fraction. That's what they wanted us to do first. They said by first differentiating this thing. Okay, so we've done that part. We've differentiated this fraction. Obtain an expression for dy over dx. Now, what's dy over dx going to be? This is the function y. Let's write that here. Y is equal to square root of that whole thing. If we write that in the power form, it would look like this. It would be 1 minus x over 1 plus x whole raised to the power 1 over 2. That's the function that we have. We want to differentiate it and find dy over dx. Now it's a power function. What we can do for this is we can use the power rule, right? What does the power rule look like? We multiply by the power, subtract 1 from the power, multiply by the derivative of the base. Let's do that. Let's multiply by the power first. It becomes 1 over 2. Subtract 1 from the power. So 1 minus x over 1 plus x, that remains as it is. Subtract 1 from 1 over 2. What does that become? 1 over 2 minus 1, that's minus 1 over 2. Times the derivative of this. 1 minus x over 1 plus x. What's the derivative of this? Derivative of 1 minus x over 1 plus x. They made us find that here first. We already found that here, right? We can use that directly. Instead of doing this all over again, we have found this derivative that's minus 2 over 1 plus x whole squared. We use that here, minus 2 over 1 plus x whole squared like this. Okay, now let's simplify this. 2 and 2, they get cancelled. We have this negative still there, right? Do not skip that. And now we're getting minus 1 minus x power minus 1 over 2. And in the denominator, we have 1 plus x power minus 1 over 2. Remember, this power minus 1 over 2 is also on the denominator. And we have 1 plus x whole squared. This is what we're getting. This is dy over dx. We can simplify this further if we want. The simplification would be that we get minus 1 minus x whole power minus 1 over 2. And in the denominator, this is 1 plus x power minus 1 over 2, 1 plus x power 2. Same basis, they're multiplying, powers get added. So this gives us 1 plus x whole raised to a power 3 over 2 in the denominator. Okay? Any problems with this? This is dy over dx. What does dy over dx tell you? This tells you the gradient of the curve. We have found that. Now, what are they asking for? We have found dy over dx now. Now they're saying, hence show that the gradient of the normal to the curve at the point xy, so at any general point xy, gradient of normal, that is this. Okay, now how do we show this? Gradient of normal, this is dy over dx, right? What is the gradient of normal going to be? Gradient of normal is negative reciprocal of the gradient of the curve, right? Negative reciprocal of the gradient of the curve. So what we do is we change the sign. So this negative becomes positive, and we take reciprocal of this. That's going to give us 1 plus x whole power 3 over 2 divided by 1 minus x whole raised to power minus 1 over 2. That's the gradient of the normal that we get. We change the sign and we take reciprocal. All right. What do we do at this point now? We have to show that this gradient of normal is this. How can we do that? We've got 1 plus x whole raised to power 1 plus x times square root of 1 minus x squared. This is what we need to show. They want us to show that the gradient of the normal is this thing. Now, how do we go from this to this? That's the question. That's the next question now. Now, first of all, there's no fraction here, right? That means we want to get rid of the fraction, first of all, so we can bring the denominator to the numerator. What does that become if we do that? It becomes 1 plus x whole raised to power 3 over 2 times 1 minus x whole raised to power 1 over 2. So when this comes to the numerator, the power becomes positive. Okay, now how do we go from this to this? Any idea about this? We have 1 plus x separate here. And we have 1 minus x squared. 1 plus x into 1 minus x, does that remind you of something? That's a plus b into a minus b, right? A squared minus b squared. But we can't do that yet because the powers are different. This is 3 over 2 and this is 1 over 2. They want 1 plus x separate, like this. We have 1 plus x power 3 over 2. We can split that into two parts. We can say this becomes 1 plus x power 1, right? We can do 1 plus x power 1. And then we have 1 plus x power 1 over 2. I can write it in as two separate parts like this. So if you have a raised to power xy, we can write that as a raised to power, I'm sorry, not xy. If you have a raised to power x plus y, we can write that as a raised to power x times a raised to power y. That's what I'm doing here. One power is, the power is 3 over 2. I'm breaking that down into two parts. I'm saying that's 1 plus 1 over 2. And then we have 1 plus x power 1 times 1 plus x power 1 over 2. So I've divided that into two parts like this. Split that into two parts. Okay, and then we also have 1 minus x whole raised to power 1 over 2. So we've got this part separate, 1 plus x, that's what we wanted there. And now we have 1 plus x. These two things have the same power. When the powers are same, bases can multiply. If we multiply the bases here, this is a plus b times a minus b. So that is going to become a squared minus b squared, and we have 1 minus x squared whole raised to power 1 over 2. And that power 1 over 2 can be written as a square root. So we get 1 plus x whole times square root of 1 minus x squared. And that's what we wanted to prove, that the gradient of the normal is this. Now that's pretty complicated, but the good news is if you get to this part, get this point, so up to this point is pretty standard, right? You get 4 out of 5 marks already. Okay, you get 4 out of 5 marks already up to this point. And then converting this to the form that's given in the question would just be 1 mark. So in case in the exam you're not able to figure this out, there's no need to worry about that. In fact, it's more important not to waste too much time on this in the exam if you still have other questions left. So you would prefer to do other questions first and then see if you have time for this 1 mark at the end or not. But before that last 1 mark, the rest of that was not that difficult, right? Okay, so that was the first part. I hope that makes sense. Let's look at the second part now. Now that's another interesting one. Again, it's very important to understand the statement. What are they saying now? The gradient of the normal to the curve has its maximum value at the point P. No, it's the second last we're doing. One more question, that is this one, 33. Okay. Okay, I'll try to be quick so we can finish early. So what were we doing? Part 2. Yeah. Gradient of the normal to the curve has its maximum value at the point P. Find by differentiation the x coordinate of P. Now, does it look like a maximum point? It does not look like a maximum point. Why is that? Because it's not the maximum point of the curve. It's the maximum point. It's the maximum value of the maximum point for the gradient of the normal. So we're not looking for the maximum point of the function. We are not going to say dy over dx is equal to 0. No. We are looking for the maximum point for the gradient of the normal. Okay, so it's basically like this. The normal would be of this direction, in this direction at different points. The normal at the point P, that's the steepest. that has the highest gradient, right? So at this point, the normal would have the highest gradient. That's the point that we're looking for. Now, how do you find that? We already have the gradient of the normal. This is the gradient of the normal. Let me write that here. Let's represent it with some letter. Let's say this is g of x. I'm representing gradient of normal using the function g. Okay, so I'm saying this is the function and it represents gradient of normal. What is this equal to? It's 1 plus x times 1 minus x squared whole power 1 over 2. That's the gradient of the normal. We are looking for the maximum point of this function. Okay, not the original function. We're looking for the maximum point of this. How do you find maximum point for anything? You find the derivative, put that equal to 0. So you find the derivative of this thing and put that equal to 0. All right, this is the gradient of the normal. We find derivative for this because we're looking for the maximum point of the gradient of the normal. So this is the gradient of the normal function. We find the derivative of this, put that equal to 0. Let's do that. Derivative of this, we can say that's g dash of x, g prime of x. It's a product, so we would have to use product rule again. We can say this is u and this is v. So the derivative is going to be uv dash plus vu dash, u as it is, into derivative of v, which is 1 over 2 times 1 minus x squared power 1 over 2 minus 1, that becomes minus 1 over 2 into derivative of this thing, which is minus 2x. Okay. Plus 1 minus x squared whole power 1 over 2 as it is into derivative of this thing. Derivative of 1 plus x, that's 1. All right. Now we simplify this and then put this equal to 0. On the right side, now we have 1 over 2 and minus 2 there. They get cancelled. And we have 1 plus x, and there's a minus x from here. Let me write that in the beginning. Minus x times 1 plus x into 1 minus x squared whole power minus 1 over 2. And then the next term is 1 minus x squared whole power 1 over 2. Okay, what do we do now? We have minus x squared from this. This is 1 minus x squared power minus 1 over 2. We can write that in the denominator. 1 minus x squared power 1 over 2 plus 1 minus x squared power 1 over 2. That equals 0. If we take LCM on the right side, what do we get in the numerator? Minus x squared. This gets multiplied with this. 1 minus x squared power 1 over 2 times 1 minus x squared power 1 over 2. Same basis, powers get added. 1 over 2 plus 1 over 2. What's that? That's 1. So we have 1 minus x squared power 1 divided by whatever, that will get multiplied with 0. And you get 0 on the other side. Minus x squared plus 1 minus x squared. And that gives us minus 2x squared minus x plus 1 equal to 0, which is 2x squared plus x minus 1 equal to 0. Can we factorize this? This becomes 2x squared plus 2x minus x minus 1 equal to 0. We get two factors from this, 2x minus 1 and x plus 1. That means either x is equal to 1 over 2 or x is equal to minus 1. What were we looking for? We were looking for the x coordinate of P. Now look at the diagram. P is supposed to have a positive x coordinate. It can't be negative. Okay, so that means this is not possible. The only possibility is x equals 1 over 2. Now do a sanity check. Does that make sense on the diagram? 1 over 2, 0.5. Yes, this is 1. So it makes sense to have this as 0.5. So that's the x coordinate that we were looking for. X equals 1 over 2. That's our final answer. That's the x coordinate of that point P. Is that all right? Let's do one more question quickly. And then you did not get the concept. What concept? Well, can you be more specific?
When we put the double derivative equal to 0.
So, okay, don't think of the double derivative. This is not the double derivative. This is not the double derivative. What does the question say? We are not putting double derivative equal to 0, right? There's nowhere where we put double derivative equal to 0. That's not, there's no logic for that, okay? What we're doing is, the question says, the gradient of the normal to the curve has its maximum value. What are we talking about? We are talking about the maximum value of the gradient of the normal. What's the gradient of the normal? This is the gradient of the normal. This is the gradient of the normal, g of x. We are representing that with g of x. Okay. Now treat it like any other function, right? This is the function now. We are looking for the maximum point for this function. Forget about what happened before. This is the function that we're talking about, okay? We have to find the maximum point for this function. How do we do that? How do you find that? We find the derivative of this, put this equal to 0. So it's not the double derivative. It's derivative of this function, whatever that function is. So we're finding the derivative of this, putting that equal to 0, and that gives us that maximum point. Does that make sense? Okay, so the maximum point that we're looking for is with respect to the gradient of the normal. That original function, that's irrelevant. We're not talking about that anymore. Okay, we're talking about gradient of normal. We find the derivative of that gradient of normal and put that equal to 0. Okay, let's do one more question, and then those of you who want to leave, you're free to leave, and we can then discuss any individual question that anyone might have after that. Let's look at this one now. This is question number 33 from the worksheet. Yes, if we're looking for for a maximum value or a minimum value, that's what you do. Whatever it is that you want to find the maximum value for or the minimum value for, you find the first derivative, put that equal to 0 for that thing. Okay. All right. This is question number 33 now. It says the diagram shows the curve y equals this for x greater than equal to 0. The stationary points are labeled t1, t2, t3, and so on. This is t1, this is t2, this is t3, this is t4. These are all stationary points of this function. We want to find the x coordinates of t1 and t2. X coordinates of t1 and t2. So t1 and t2 are the first two stationary points here. How do you find stationary points? How do you find turning points? You find the derivative, put that equal to 0. All right, so that's what you have to do here. Find the derivative, put that equal to 0. Now, what's the function? The function is y equals 10 e raised to power minus half x times sine of 4x, and x is greater than or equal to 0. That's the domain that we're given for this. Now, how do we differentiate this? It's a product again, right? 10 we can keep outside as it is. That's multiplying with the whole thing, and we can say this is u and this is v. What's the derivative? uv dash plus vu dash. U as it is, that's e power minus half x times derivative of sine of 4x. What would that be? Derivative of sine is cos, so it becomes cos of 4x times 4, right? Derivative of 4x, that's 4, plus sine 4x as it is, right? V as it is, times derivative of e power minus half x. So e power minus half x remains e power minus half x, but then you have to multiply with the derivative of this, which is minus half. This is the derivative. Now, since we're looking for the stationary point, we put this equal to 0. put the derivative equal to 0. On the other side, we have 10, and then we can also take e power minus half x common here, right? And then we are left with 4 cos of 4x. Remember, this 4 cannot multiply with this 4x. This 4 is outside cos, right? So 4 cos 4x minus half sine of 4x. So I've taken this common outside, e power minus half x. Now, what does that mean? These are factors, right? Two things multiplying, and the result is equal to 0. What that means is either the first thing is equal to 0, 10 e raised to power minus half x, either that should equal 0, or 4 cos 4x minus half sine 4x should equal 0. Now, what do we get from this? Nothing, because we get e power minus half x equal to 0. And then if you try taking log from this, you cannot take log of 0. So this is not possible. You don't get anything from this. Okay, now let's look at the second equation, the one on the right side. How do we solve this equation? We can first simplify this by multiplying by 2, so that it becomes 8 cos of 4x minus sine of 4x that equals 0. What we can do now is we can say it becomes 8 cos 4x equals sine 4x, divide cos 4x on the other side, and that will convert to tan, right? Sine 4x divided by cos 4x, that equals 8. And we have tan 4x equal to 8. That's the equation that we now need to solve. We are looking for the first two values of x. Okay, you can do it using substitution if you want. In this case, since the interval is just x greater than equal to 0, 4x is also going to be greater than equal to 0. You can do it directly as well if you want. If you prefer using a substitution, you can do that. That's okay. Let's see what we get from this. Find the basic angle first of all. What's the basic angle? Tan alpha equals 8. What's the basic angle? Or let me actually do it the standard way in case it ends up confusing anyone. So what do we do generally for such problems when the angle is not just x or theta? We used to use a substitution, right? Let's do that. You say let a equals 4 times x. Now if a is equal to 4 times x, what's the interval for a going to be? You input 0 in place of x. 4 times 0 is still 0. So a is also going to be greater than or equal to 0. And now we solve this equation, tan of a equal to 8. How do we solve this? We find the basic angle, tan alpha equals 8. What's the basic angle? Tan inverse of, is it in radians or, okay, this is supposed to be in radians. Although the question does not specify, remember you always use radians in all P3 topics unless the question specifically uses degrees somewhere, okay? In this case, you can't use degrees at all because there's an x multiplying outside. You can't have a number in degrees multiplying outside anywhere. Degrees can only be inside sine, cos, and tan. They can't be outside anywhere. Okay, so, but generally just remember, if the question does not specify anything, always use radians. Okay, tan inverse of 8. What do we get? 1.4464. That's the basic angle that we're getting. Tan is positive. Where is tan positive? Tan is positive in the first quadrant or in the third quadrant. Okay, so that means we have to consider all angles greater than equal to 0. The first angle that we're getting is this, and the next is this. Okay, so the first angle is a equal to 1.4464. And the second angle is pi plus 1.4464. Now put that substitution back and you get 4x equal to 1.4464 and 4x equal to pi plus 1.4464. What's the value of x that we get from this? The first angle that we get is 0.3616. You have to give your answer to 3 decimal places. It becomes 0.362. And the second answer, 1.147. They wanted us to find the x coordinates of the first two stationary points. These are the first 2 points that we're getting, 0.362 and 1.147. Okay, that's the first part. We say this is T1, the smaller one, right? This is a smaller x coordinate, this is a bigger x coordinate. So the smaller values for T1, the bigger values for T2. So we find those two x coordinates. That's the first part. Let's look at the second part now. The second part says it's given that the x coordinate of Tn, x coordinate of Tn is greater than 25. Find the least possible value of n. Okay, now how do we think about this? You see, this is T1, this is T2, T3, T4. Now the curve is continuing like this. They're only showing part of the curve, right? It'll continue the same on the same pattern like this. It will go like this, and then this, and then this. You see, the turning points are their y coordinates are getting closer and closer to 0. So it will continue like this. So you have T5 here, and you have T6 here, you have T7 here, and then at some point they're saying you have Tn. Okay. And Tn is greater than 25. What's the value of n, the first value of n, when it becomes greater than 25? How do we find that? We have already found T1 and T2. How do we find the next stationary point, and then the next stationary point, and then the next stationary point? The first stationary point was this 0.362. And then the second one was 1.147. How do we get to the next one after that? The next one would be that you go one full circle and then come back to this point, right? One full circle and come back to this point. That will be the next value. What about the next one after that? One full circle and come back to this point. That will be T4. And you continue like this to find the next and next and next stationary points. Okay. Now, what would the pattern look like? We found T1 earlier. What was T1? If you look at the pattern, it looks something like this. If I were to show another step here, x was equal to 1.4464 divided by 4. And here x was equal to pi plus 1.4464 divided by 4. So T1 is 1.4464 divided by 4. That is 0.362. And then T2 is pi plus 1.4464 divided by 4. And that gave us 1.147. How are we going to get to the next angle after this? We add pi more to the previous one, right? 180 degrees, pi radian more, you get to the next one. And then for the next one, you add pi more like this. So you're going like this. Let me show that here again. So this is the first angle, 0.362. For the next one, what you do is you add pi. For the next one after that, you add another pi. Then for the next one, you add another pi, then another pi, then another pi. You keep going on like this. So the next value here, T3, what would that be? It would be 2 pi, one full circle, plus 1.4464. But then you divide by 4, and that gives you another value. And then T4, it will become 3 pi plus 1.4464 divided by 4, and that will give you another value of x. Let me just evaluate a couple of these for you. This was the first one that we were getting. Add pi to it, and then divide by 4. This is the first one, and then you see what's adding after that? Just pi over 4 to the previous value. If I were to evaluate this, the next value would just be pi over 4 plus, okay, I'm sorry, it's not working, 1.47 plus, The next value here, this one is going to be 1.932 for you. And then the next one after that, that's going to be 2.718 for you. And this pattern continues like this until you have Tn somewhere. Until you have Tn somewhere. Tn has to be greater than 25. Now, one idea is that you look at this pattern and write down the nth term yourself. That's one idea. Or since you're adding the same number again every single time, you could also think of it as an arithmetic progression that you did in paper one, arithmetic progression. And you could use that formula as well, a plus n minus 1 times d. If you were to try and figure it out directly from here, you see what's happening in each term? If there's 1 here, if there's 2 here, you're adding pi here. If there's 3, you're adding 2 pi. If there's 4, you're adding 3 pi. If there's n, you would have n minus 1 times pi plus 1.4464 divided by 4. That will be the nth term of this. You put that greater than 25 and you'll find the value of n from that. Or a relatively easier way of thinking about this could be that you find the differences between these values. They are at the same horizontal gap on the graph. What's the difference between these values? You can find them in decimals as well, and that's perfectly okay. 1.147 minus 0.362. What's the difference that's turning out to be here? What's the difference turning out to be here? 0.785. This is 0.785. Okay, then find the next difference, 1.932 minus 1.147. What's that? 0.785. And then again, 0.785 or 786. There might just be a random of error there. But you're adding the same value again and again to get the next one, right? You're adding the same number again and again to get the next value. That means we can treat it as an arithmetic progression, which is a plus n minus 1 times d. What's the first term? The first term is 0.362 plus n minus 1 times the difference, which is 0.785. This is the nth term. This has to be greater than 25. You solve this and find the value of n from this 0.362 plus 0.785n minus 0.785, that's greater than 25. And that gives me 0.785n, that's greater than 25, plus 0.785 minus 0.362. That's 25.423, and n is greater than 32.4. What's the least value of n that satisfies this inequality? The least possible value of n would be 33. And that is your final answer. Quite tricky, but that's what you would do here. You look at the pattern that's emerging for those values of x, for those stationary points. Looking at that pattern, you find out what the least possible value of n is going to be. Yes, Ibrahim.
सर
वालेकुम अस्सलाम।
सर लेकिन जैसा आप ग्राफ में देखें उसके अंदर भी पाई ऐड हो रहा है, और जब आप दूसरा वाला ग्राफ भी देखेंगे उसमें भी पाई ऐड हो रहा है, तो मैं तो पाई ऐड करके कर रहा था, लाइक T1 और T2 के दरमियान पाई का डिफरेंस होना चाहिए ना, तो
हाँ,
हाउ इज इट पाई?
क्यों, क्या रीजन है उसकी?
चलिए, जब ग्राफ की एक मैक्सिमम टू मिनिमम जाता है, जो साइन कॉस का होता है उनमें 90 का डिफरेंस होता है और 180 का डिफरेंस होता है ना।
This is sine of 4x. Period is divided by 4. So if it was a difference of pi earlier, now it becomes pi over 4.
ओके सर.
Right?
अच्छा, वो ट्रांसफॉर्मेशन से है ये. अच्छा.
4x है ना ये? So if period was pi earlier, now it becomes pi over 4. If it was 2 pi, now it becomes 2 pi, pi over 2 basically. If the
ओके
gap earlier between the stationary points was pi over 2, now it becomes pi over 8, and so on, right?
ओके सर, आई गॉट इट. थैंक यू.
Any questions on this? Again, don't get scared by looking at this if this is one of the first few questions that you're doing, because this is like one of the most difficult ones that you will find on differentiation. 90-95% of those are going to be much simpler than this. And once you've done enough practice, at least like 30-35 questions from the worksheets and from recent papers, you should be confident that you will be able to tackle most questions like this. Okay, generally this is something that comes as one. This questions like these, they're like 1 or 2 out of the 10-11 questions that you have in the paper. You will leave these questions for the very end, so that you're done with the rest of the paper, the ones that you can easily figure out, most likely 8 to 9 questions at least. And then these 2-3 questions, they will require more thinking, and you'll try to get as many marks as you can out of these questions as well then at the very end. The key thing is, don't end up getting stuck at a question like this in the middle of the paper, because that can basically ruin your paper, because then you can end up having very little time for the easier questions, and you would end up doing careless errors in those questions then. So make sure to attempt the questions that you can easily figure out in the first go, and then come back to questions like these at the very end. Okay, so that's it for today. If anyone has any individual questions to ask, you can stay back. Otherwise, you're free to leave. Tomorrow we are starting integration, inshallah. Okay, integration, and then differential equations, and then finally iteration. Hopefully, we should be done by the first week of March, inshallah. Okay, so we'll just have those 3 topics left. Yes, Ibrahim. So anyone who wants to leave, you're free to leave. I'll see you again tomorrow, inshallah, when we start integration. If you have any questions, you can stay back. Allah Hafiz. Yes, Ibrahim. WhatsApp पे send किया. Okay. इब्राहिम ग्रुप पे सेंड किया आपने? You want me to figure out what the mistake is in your working?
यस सर, फर्स्ट वाले का मिस्टेक बता दें, पर सेकंड वाले का जो है वो थर्ड पार्ट नहीं समझ आया था, जैसे मैंने कहा गिर दीजिए प्लीज.
Okay. Okay, you put cot 2 equal to 2, 1 over tan t equals 1 over 2. Okay, so tan is positive. That's either the first quadrant or the third quadrant. Third हो नहीं सकता because वो range से बाहर चला जाएगा. You're getting one answer in the first quadrant, tan inverse of 1 over 2. Is that correct? जो आपने निकाला है यहाँ पे?
यस सर.
Okay, 0.4636, and then you're saying you're inputting in that equation for x, and you're not getting the correct answer?
यस सर.
T minus tan of answer minus 0.0364, at which the gradient is equal to 2. So let's input this in the gradient. Cot of t, right? 1 over tan of answer. Okay, नहीं वो तो x था ना. अच्छा. 1 over tan of 0.4636. So I said the 2 so the value of t is correct, and when you input that value of t in that equation, yeah, it's सही लगा. This should be correct. What's the problem?
मेरे ख्याल से सर फिर एमएस में गलत होगा.
अच्छा, ये मुझे बताएं. Do you have the paper number for this?
नो सर, ये आपकी वर्कशीट सही है ना?
अच्छा, इस दूसरी वर्कशीट में देखते हैं, इसमें पेपर नंबर्स लिखे हुए हैं. P3 differentiation. I'll be uploading these other worksheets as well. Sort P3 differentiation. अच्छा, चलिए तो मार्किंग स्कीम है. हो गया. अच्छा, क्वेश्चन में क्या था उसमें? T minus tan t and ln cos t. Okay, let's search for that question quickly.
फिर तो इंटीग्रेशन नहीं है.
नेमिंग गलत हो गया, मुझे लगता है कि मसला इसमें. मार्किंग स्कीम है. trig. This is differentiation. What I'll do is I will try to. आप ये देख सकते हैं कि ये किस उससे है, या ओके, ये आसान होगा फाइंड करना है इससे. at which the gradient is equal to 2. Right. 9709, at which the gradient is equal to 2. Okay. June 14, paper 3-2. सही है, ये आ रहा है -0.0664.
हाँ जी.
हो सकता है उसकी जो वर्कशीट के साथ मार्किंग स्कीम है उसमें कोई प्रिंटिंग एरर हो सकता है, लेकिन चेक दैट एज वेल. Worksheet P3 differentiation. क्वेश्चन नंबर क्या थे? 34.
34 है.
इब्राहिम,
हाँ जी सर.
क्या लिखा हुआ है?
34 माइनस 0.0364.
यही तो आ रहा है आप.
सर ये कैसे आ रहा है? 0.464 आ रहा है.
इब्राहिम, आपने खुद ही लिखा हुआ है बेटा ये.
सर
अच्छा,
ये इनकरेक्ट किया मैं।
मुझे लगा था आपने x की वैल्यू लिखी हुई तो आपने t की वैल्यू निकाली है ना, दिस इज द वैल्यू ऑफ t। आप अभी तो मैंने इनपुट किया आपके सामने, इसके अंदर इनपुट करेंगे तो x की वैल्यू आएगी ना, आपने तो t की वैल्यू निकाली है, उसके अंदर इनपुट करेंगे x की वैल्यू यही आती है।
अच्छा 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 अच्छा।
मुझे लगा आप कह रहे हैं कि आपने ये वैल्यू निकाली और ये गलत है, ये तो सही है। x की
जी।
वैल्यू x की वैल्यू फाइंड फाइंड करेंगे ना वहां पे।
हाँ जी समझ गया।
जी।
आंसर एक और जो 48 क्वेश्चन था। 48।
48।
48 का लास्ट पार्ट।
अच्छा, मुझे यहाँ पे शेयर करने दें। ओके, नाउ दिस इज अ गुड क्वेश्चन। ये उसी तरह से नॉर्मल नॉर्मल वाला क्वेश्चन क्या है ना, आपने क्वेश्चन स्टेटमेंट को समझना है, वो क्या बात कर रहा है। उसने कहा है find the value of x for which the gradient is least. We are not looking for the minimum value of the function, we are looking for the minimum point of the gradient. Right now, what's the gradient? Dy over dx that you found here, this represents the gradient. What you do is you treat this as a new function. You say this is the gradient function, which is e raised to power minus 2x times minus 1 plus tan x whole squared. Forget about whatever was the original function. That does not matter. This is the gradient function. You are looking for the value of x for which this function is least, when this has a minimum value. How do you find minimum point of anything? You find the derivative, put that equal to 0. So that's what you would do here. Find the derivative of this, put that equal to 0, and you'll get a value of x from that.
ठीक है सर। सर लेकिन वो उससे ग्रेडियंट लीस्ट तो नहीं आएगा, ग्रेडियंट जीरो आ जाएगा। वो लीस्ट वैसे नहीं होगा।
ग्रेडियंट का डेरिवेटिव है ना ये।
तो सर वो तो नेगेटिव में भी जा सकते हैं ग्रेडियंट।
नेगेटिव में जा सकते हैं, क्या मतलब? जा सकते
मतलब
हैं।
ग्रेडियंट
बिल्कुल
इज लिमिट बताना है ना, तो वो तो माइनस
बिल्कुल
टू भी हो सकता है, माइनस थ्री भी हो सकता है, वो तो जीरो से
बिल्कुल।
कम हो जाएगा।
तो हम ये तो नहीं कह रहे कि जीरो आपका लीस्ट ग्रेडियंट की वैल्यू है। हम कह रहे हैं जब ग्रेडियंट लीस्ट होगा तो जो ग्रेडियंट का डेरिवेटिव, अगेन फॉरगेट अबाउट द ग्रेडियंट, ये एक फंक्शन है, ये एक
हम्म
फंक्शन, ठीक है।
हम्म हम्म।
दिस फंक्शन रिप्रेजेंट्स द ग्रेडियंट, ओके। ये
ओके।
एक फंक्शन है, इस
हम्म।
फंक्शन का मिनिमम पॉइंट निकालना है। कैसे निकालते हैं?
वो तो जीरो इक्वल टू जीरो रख लेंगे।
इसके डेरिवेटिव निकालेंगे, इसको जीरो से इक्वेट कर देंगे। तो
हाँ।
इसके डेरिवेटिव को जीरो से इक्वेट कर रहे हैं ना, इस फंक्शन के डेरिवेटिव को। ग्रेडियंट को तो जीरो से इक्वेट नहीं कर रहे हैं,
अच्छा
ग्रेडियंट के ग्रेडियंट को इक्वल टू जीरो कर रहे हैं, तो वो आपको उसका टर्निंग पॉइंट देगा।
अच्छा अच्छा अच्छा। ठीक है।
राइट।
सर लेकिन ये वर्ड मार्क के लिए ज्यादा वक्त नहीं है।
अच्छा, वन मार्क है ये।
हाँ जी।
अच्छा, ग्रेड वैल्यू ऑफ एक्स फॉर व्हिच द ग्रेडियंट इज लीस्ट। ओके, फिर ये डायरेक्टली भी हो सकेगा। डेरिवेटिव क्या आ रहा है आपका?
मैं
This is one idea that generally works for all functions. But since this is one mark और ये trigonometric function है, इसको करने का एक quicker तरीका ये हो सकता है, this is the gradient, right? E power minus 2x times minus 1 plus tan x whole squared, right? ये function है ना? और
जी।
आपको उसने कहा हुआ है कि x 0 से pi over 2 के दरम्यान में है।
हाँ जी।
X is between 0 and pi over 2. Okay. अब इस फंक्शन की मिनिमम वैल्यू कहां पर हो सकती है? इस फंक्शन की मिनिमम वैल्यू कहां पर होगी? लेट्स थिंक अबाउट दिस। ये जो चीज है e पावर एनीथिंग, That's always positive, right? ये कभी नेगेटिव नहीं हो सकता ना. E is a positive number.
हाँ जी.
पॉजिटिव नंबर की जो मर्जी पावर लें, दिस इज ऑलवेज गोइंग टू बी पॉजिटिव.
हाँ जी, वो ऊपर प्रूफ किया मैंने. हाँ जी.
ये क्या है? ये स्क्वायर है.
ये
स्क्वायर
भी
का क्या?
ऑलवेज
स्क्वायर की मिनिमम वैल्यू भी क्या हो सकती है?
पॉजिटिव.
जीरो भी हो सकती है ना. जीरो का स्क्वायर है जीरो.
हाँ 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 हाँ.
तो
यस.
अंदर वाला पार्ट जो है वो अगर जीरो हो जाएगा तो ग्रेडियंट जीरो हो जाएगा. ग्रेडियंट यहाँ पे नेगेटिव नहीं हो सकता इस केस के अंदर. इस पर्टिकुलर एग्जांपल के अंदर यहाँ पे ग्रेडियंट नेगेटिव नहीं हो सकता बिकॉज द
हाँ
आउटसाइड पार्ट
हाँ
इज
हाँ हाँ.
पॉजिटिव एंड दिस पार्ट इट्स मिनिमम वैल्यू इज, इसकी मिनिमम वैल्यू क्या? जीरो.
जीरो.
अब जीरो वैल्यू कब आती है इसकी, वो फाइंड करने के लिए आप ये अंदर वाले पार्ट को जीरो से इक्वेट कर दो. You get tan x equal to 1, x equals pi over 4 in that interval.
ओके. ओके.
Okay. Now, this is specific to this question because ये gradient इस form का है आपका, right?
हाँ जी.
अगर वो किसी और फॉर्म का होता, ये ट्रिग्नोमेट्रिक फंक्शन नहीं होता और ये स्क्वायर नहीं होता, दिस वुड बी द जनरल मेथड दैट यू यूज इन प्रॉब्लम्स लाइक दिस. लेकिन यहाँ पे क्योंकि एक मार्क है, इसका मतलब ये बहुत लंबा हो रहा था. दिस शुड हैव बीन मोर समथिंग मोर एफिशिएंट, सो दैट्स द मोर एफिशिएंट वे ऑफ डूइंग दिस.
बस जब भी ग्रेडियंट की हमने लीस्ट वैल्यू निकालनी है तो हमने उसको एक फंक्शन की तरह ट्रीट करके उसका डेरिवेटिव ले
उसका
लेना
डेरिवेटिव निकालने, उसको जीरो से इक्वेट कर देना.
है. बस ठीक है. ऑलराइट. ठीक है. थैंक यू सो मच सर.
ठीक है, ओके, नो प्रॉब्लम.
अल्लाह
अल्लाह
हाफ़िज़.
हाफिज़. मोमेंट ओलंपियाड मैथ बेटा मुझे खुद भूल गई है. आई डोंट रिमेम्बर दैट एनीमोर. मूसा मोहसिन, गुड टू सी यू. आई होप यू आर डूइंग वेल. लम्स में होते हैं आप? All right, so that's it for today then. I'll see you again in the next class. Tomorrow we're starting integration. I love this.